This is homework 16 answers, or just homework 16. First problem, absolute value of x is greater than 2. So we need to remember we're making a positive and a negative side here. So this would break down for our positive side would be x is greater than 2, and for our negative side would be x is less than 2. So when we graph this, we've got, our negative side would be x is less than negative 2. So when we graph this, our numbers are negative 2 and 2, open circles for both of them. This one, less than negative 2 would be an open circle going to the left, and greater than 2 would be an open circle going to the right. So this is an OR equation. So we need to remember the OR in here. And because it's an OR, you can just leave it just how it is, writing the OR in. Our next problem, B, y, the absolute value of y plus 3 is less than 8. So when we set up our positive side, we've got y plus 3 is less than 8, and our negative side, y plus 3 is greater than negative 8. So when we solve for y, we'd subtract 3, we'd get y is less than 5, and our other side we'd subtract 3, and we get y is greater than negative 11. So now let's take a look at the graph of this. When we graph this, our numbers are negative 11 and 5. So what are we in comparison? Whoa, where'd we go? Get out of that. Here we go. Excuse me, didn't know where I went. Okay, so in comparison to the 11, we're greater than negative 11, so that's open circle going to the right. And what are we? We're less than 5, so that's open circle going to the left. Now because those are going in on themselves, that's an AND equation. So we don't want to leave it like this up above on ANDs. If it was an OR, we'd just write OR in between like we did on the previous problem. But when it's an AND, we need to change it. So when it's an AND, we're going to change it. We're going to write our variable in the middle. We're going to rewrite our numbers in numerical order, just like they are on the number line. So our numbers are negative 11 and 5. And now go back to where we were up here and say, well, between the variable and the negative 11, we were eating the variable. Notice how it changed. Okay, but it's still eating the variable. It's still open to the variable. And between the variable and the 5, it was eating the 5. And so that would be the proper way to write this. And we'd read this all real numbers greater than negative 11 and less than 5. So C says m minus 2.2, that absolute value is greater than 3, so we'd have m minus 2.2 greater than 3, and our negative side m minus 2.2 less than negative 3. So on our left side, we're going to add 2.2 to both sides. M is greater than 5.2. We'll still add 2.2. Add 2.2. Negative 3 plus 2.2 is negative 0.8. So our graph We are at negative 0.8, and we are less than negative 0.8, and 5.2, and we are greater than. So is that an and or an or? That's an or, so we can just write in the word or and leave it how it is. Problem D. D says the absolute value, of 9 plus x is less than or equal to 7. So we'd have 9 plus x is less than or equal to 7. On our other side, we'd have 9 plus x is greater than or equal to negative 7. What would we do? Subtract 9, subtract 9. X is less than or equal to negative 2. And same steps on the other side. That would make negative 16. So our graph here, we've got our numbers are negative 16 and negative 2. We are greater than or equal to negative 16. We're eating the variable. We're less than or equal to negative 2. We're eating the number. So is this an and or an or? This is an and. So we need to change this. So we rewrite negative 16, negative 2, put our variable in the middle. What were we eating up here? We're eating our variable. What were we eating up here? We're eating our number. And now that makes that an and equation answer. Let's look at the beginning of these. And hopefully when we start to notice this, notice at the beginning how this sign was open to the left, and it's an or, and this one's open to the right, and it's an and that'll always be the case as long as there aren't any funky negatives or stuff like that outside. So when it's just all positives, and then things will change, and you'll see how they change as you move along if you pay attention to that. But for the most part, if it starts off and it's open to the left, it'll be an or, and if it starts off open to the right, it'll be an and there are some things that'll change that, but that's how it goes. Let's skip a couple because the rest of these are all going to be pretty much the same until I. So let's do I together. So I says the absolute value of 3 plus r plus 7 is less than 10. So this should be an and equation. Now we have stuff outside of our absolute value, so we need to get rid of that first. We want just our absolute value on one side, then we do our positive and negative sides. So now we do our positive and negative side. 3 plus r is greater than negative 3. Subtract 3. R is less than 0. And subtract 3, and r is greater than, what is that, negative 6. So this is going to be an and equation. We're at negative 6 and we're at 0. We're greater than negative 6, going to the right. Less than 0, going to the left. So I need to change this back to an and equation. I'll rewrite it. My number's in order. Our variable in the middle. What were we eating up here? We're eating the variable. Oops, put the right variable in there. We're eating the r, so we eat the r. Eating the 0, eat the 0. all real numbers greater than -6 and less than 0. So that would be, J is going to be the same. We'll just add 1 at the beginning. K will be the same. We'll add 4. L will be the same. We'll add 1. Let's do M. So M has the absolute value of 2x minus 4 over 5, and that's going to be greater than 4, so looks like this should be an OR problem. So we've got our absolute value by itself, so we're going to do our positive and negative side. 2x minus 4 divided by 5 is greater than 4, and our negative side, 2x minus 4 divided by 5 is less than -4. So now what's happening to our variable? Well, this whole top of the equation, because the fraction bar is its own grouping symbol, is being divided by 5. So we want to undo that first. So we'll multiply both sides by 5. That gets rid of that 5 on that left side. That's why we did that. So we're left with 2x minus 4 is greater than 20. Now we should be able to solve this just like we do all of our problems. Inverse operations. Divide by 2. All real numbers greater than 12. Our steps are going to be the exact same on the other side. We'll get different answers, but same steps. So we'll multiply by 5 on both sides. Our 5 simplify, that's why we did it over there. 2x minus 4 less than, that makes -20. Our steps are still the same. We're still adding 4, just like we did over on this side. This time, though, we'll get -16 divided by 2, and we're at -8. So if we were to graph this, we'd say our numbers are -8 and 12. What are we in comparison to the -8? We're less than. What are we in comparison to the 12? We're greater than. That looks like an OR, so we just write in the word OR in between, and there's our answer. N looks like it's going to be the same. We're just going to need to subtract 22. N's real similar to like I, J, K, and L. O, let's do O. That's a little bit different. So O here. Get rid of this. O says 1/2 times the absolute value of m plus 3 is greater than or equal to 4. So the first thing we need to do is get the absolute value by itself. So what's going to undo multiplying by 1/2? Well, multiplying by its reciprocal. What's the reciprocal of 1/2? 2. 2 over 1. So we'll multiply both sides by 2. See that? Now that leaves us with what's on our numerator here, which is a 1. 1 times anything doesn't do anything to the problem. So this is just the absolute value of m plus 3 is greater than or equal to 8. Those are equivalent problems there. Now it's just like all the rest that we've done. We should be able to do this no problem. Positive side, m plus 3 greater than 8. Negative side, m plus 3 less than or equal to -8. Subtract 3 greater than or equal to 5. Subtract 3 less than or equal to -11. Our numbers are -11 and 5. What are we in comparison to -11? We are less than or equal to. Don't forget to fill that in. And what are we in comparison to the 5? We are greater than or equal to. So this is an or, so we can just write the word or in there, and that's our answer. So let's do the word problems here. On your basketball team, the starting players' scoring averages are between 8 and 22 points per game. Write an absolute value inequality describing the scoring averages for the players. So on this, we're going to kind of have to work backwards, right? Knowing what we did at the beginning. Remember when I compared those first two problems? So what we can get out of the information, this is 2a, right? So is that we want to be between 8 and 22 points. So we could make ourselves an inequality. That did this, so our absolute value, right, an absolute value inequality. Okay, so just our regular old inequality for this would be 8 and 22, and we want to be greater than or equal to 8 and less than or equal to 22. So that's just our inequality statement. So we want to go now. What are we going to do to get this to turn into an absolute value inequality? So let's mess around with this for a second. So when we look at this, we want to take an average, and here's how we'll find this. The average between 8 and 22. Well, what's 8 plus 22? 8 plus 22 makes 30, right? And 30 divided by 2 is 15. So the average is 15 by taking 8 plus 22 divided by 2. Alright, so now to set up our equation for an AND equation, then an AND absolute value inequality, then that means that we're going to want to subtract our average. So we're going to say x, the absolute value of x minus 15, right? And now this is an AND, so we're going to start off going this way. So it's going to be less than or equal to. And now from our average, say we were at 15, right? What do I need to do to move to 22? Or what do I need to do to move to 8? So we need to move 7 units, either add 7 over here or subtract 7 over there to go to the 8. So I'm going to say is less than or equal to 7, because that's how much we'd need to move. So now this is our answer. And let me show you kind of how we'd go about, because I've just done this so many times, that I understand the pattern and how it works. If we were to solve this, so try to go from this step here, like this was our problem, and get back to the inequality statement, what would we do? We'd set up our positive and negative side, so we'd say x minus 15 is less than or equal to 7, and our negative side, x minus 15 is greater than or equal to negative 7, right? So then what would we do? We'd add 15. We'd add 15. And you'll notice that 7 and 15 make what? Make 22. That's what we wanted to have. Look at what we've got on this half right up here. See that? It's the same exact thing. And now what are we doing on the other side? Adding 15 and adding 15. Well, what's 15 minus 7, or negative 7 plus 15? Makes 8. Or greater than or equal to 8. That's what we have over on this other side. Right up here. Okay, so the secret, what goes inside with our absolute value, is going to be the average of our two numbers. And what goes on the other side, what our constant term is how we move from our average to those two numbers. So we can, maybe B will be a similar problem. The test scores in your class range from 60 to 100. Write an absolute value inequality describing the range of the test scores. So perfect. So 2C will be a perfect problem for us. 2C. Let's erase the rest of this. So for 2C, our numbers were 60 to 100, right? So 60, put our variable in the middle, to 100. We want to be greater than or equal to 60 and less than or equal to 100. These are our test scores, right? So then what's the average of 60 and 100, right? It's going to be x minus the average, the absolute value, and then that would be less than or equal to. Now the signs would change. If it's an or, we'd reverse the symbol, and that would be the difference. And that's how we go from the average to the outside. So I'll just call that the difference. So our problem, x minus 60 and 100 add together to make 160, right? 60 plus 100 divided by 2. So that's 160 divided by 2, which is 80. So x minus 80, absolute value of that, less than or equal to. Now from 80, what would I need to do to move to 100? I need to go up 20, right? Or from 80, I need to go down 20 to go to 60. So that's how we're doing that. And that is our answer. And it will work. We could check ourselves by saying x minus 80 is less than or equal to 20, and x minus 80 is greater than or equal to negative 20. When we add 80, we get less than or equal to 100, right? And when we add 80 on this side, negative 20 plus 80, and that's where we get 60. So when we graph that, we've got 60 and we've got 100, and we're less than or equal to 100, greater than or equal to 60. That's an and inequality, just like we made up here. So there it is. That proves that we're doing it right. And that's good for the homework for today.